Stretches are pretty easy. It's when we start to deal with our H and K, now called C and D, value that things can start getting a little interesting. So first of all, not a lot changes from our basic transformation equations. Now the function is sine or cosine. So there's a few little things that we need to recall in trigonometry because we do have these different letters for a reason. So first of all, A, we're used to this. This is our vertical stretch. It's our vertical stretch factor. We're used to that. It can also be a reflection over the x-axis. And that's, of course, if A is negative. So all of that is just like chapter 1. What we need to make sure that we recognize when it comes to trigonometry, the absolute value of A is now also called the amplitude. And as we discussed, that's the distance from the center to the top, the center to the bottom. So, B, well, we already saw B. B is still a horizontal stretch. But we're always careful with the B because it's a horizontal stretch factor of the reciprocal. It can also be a reflection over the y-axis, of course, if B is negative. All of that's the same. What we need to understand for trig is this affects the period. So that's where trig gets pretty specific, that we're going to be discussing the period when we're discussing the B value. So that takes us to C. C operates like H, but it's C, because C, although still a horizontal translation, in trig, we call it a phase shift. And again, thank goodness you guys aren't writing the diploma, but when I was marking a trig equation on the diploma, if they didn't put phase shift, we couldn't give them full marks. So you couldn't just say pi over 3 left. A phase shift of pi over 3 left became a critical piece of information. So the language changes just a little bit. So phase shift is the important thing to recognize. No, but you're going to read it. You're going to start seeing our tests we say in a phase shift of and a phase shift of. So that's kind of what happens there. D still operates the same way K does. It is still the vertical translation. And this one I don't understand as well. In trig, we call it a vertical displacement. So I don't know why that word gets changed. It just does. So those are a few things that we need to be aware of. A little bit of change in language. We discussed period, we discussed amplitude, we discussed phase shift and vertical displacement when we start talking about these different things. The effects, however, are the same. This is C, this is D. Okay, let's start to play with some of them. So when we start to look at these graphs, what we have to understand is just like in our transformations, the C value is inside the brackets. The D value is not inside the brackets. Okay, we have to be able to separate those two effectively. So when I read this, y is equal to sine x minus 30, because it's in the brackets, I know it's a C value. So technically, we should be saying this is a phase shift 30 degrees right. Technically, that's exactly what we want to see. And as I alluded, when I was marking diplomas, without phase shift, they dinged you. The range. Well, C is an effect on the x values, so would this affect the range at all from the base graph? No. So the range is still our basic -1 to 1. X-intercepts and degrees. Okay, let's pull those up so we've got them. If it's sine theta, our x-intercepts were, and we'll do them in degrees this time because that's what it says, 180 degrees N, NEI. And if it was cosine, it was 90 degrees plus 180 degrees N, NEI. Just so we don't have to keep flipping back. I'll just put those at the top. So, sine x-intercepts. Let's really think about what happens here. I need to take this, and I need to move it 30 degrees to the right. So people will do this. Oh, that's nice and easy. It's 210 then. Well, that doesn't make any sense, does it? Because do I want it happening every 210 degrees? Does that make any sense to anybody else? So we know that's wrong just by inspection. It doesn't hold water. This doesn't operate the same way as a stretch does. So what is it going to be? Well, we need to think, where was my first x-intercept? Well, for sine, it was at 0, 0, right? That makes sense. Sine is nice and easy. It starts at 0, 0, and it got moved 30 degrees to the left. So would you agree now my first intercept is at 30 degrees? I said left, I meant right, I apologize. Now, how far apart do those intercepts happen? Now, did that change with my physically moving it? Does that 180 degrees apart change at all? Nope. So there's my 180 degrees N, NEI. So really think about what's going on. Don't just do something. Think about what you're writing down. Okay? Because I've seen that a lot. Oh, it's just 210 degrees N. No, you did no thinking. What about the y-intercept? Well, if the x-intercept moved, does it make sense that my y-intercept moved? So how am I going to figure out where my y-intercept is? I'm just going to go back to the very basic definition of a y-intercept. When does a y-intercept happen? Perfect. I'm just going to discover what the value of sine of negative 30 is. So I go to my handy dandy funky unit circle because that's where all the answers is, and 30 degrees is one of those ones. I look at negative 30, which is the same as 330. And what is the sine value, please? The sine value, not the radian value. The sine is the y. You're all staring at me like I've got the unit circle on my face. I don't. Negative 1/2. So, simple application. Think about it a little bit though. Phase shifts mess students up. Y is equal to sine x plus 2. How do I know this is a D value and not a C value? It's not in brackets, and that's a basic definition. It's not in brackets, so I know this is a vertical displacement 2 units up. So I'm just trying to throw in that good terminology so we've got it. What does my range become if I move it up 2 units? Well, it affects the y values. I look at my original range and I add 2. Nice and easy. Okay, deep breath, guys. We're doing x-intercepts. Yeah.
Is that 1, 3, or is that supposed to be negative 1, 3?
Oh, it's 1, 3.
Oh, no, never mind, because the other one moves up like that.
Yeah. X-intercepts, always the bugaboo. Okay, we can't stand x-intercepts. They take so much time. I'm dealing with sine, but hold on, stop. Whoa, what's my range? And an x-intercept happens when y is? So there are, what? None. Nothing to worry about there. Okay, so we can move this up and get rid of the x-intercepts just like we could with parabolas. So that range can kind of help solve some of the problems. All right, my original y-intercept was at 0, 0, and I moved it 2 units up. Where is my new y-intercept? Beautiful. Nice and easy. All right, let's put it together, and what have you got? What is happening? First thing we say, we've got a phase shift. Left, 60 degrees. Vertical displacement. Down, 1. So left, down. All right. What did that do to my range? Well, just take the range, which was 1, -1, and move it 1 down. That is going to take me to -2, 0. X-intercepts, here we go. We need to consider where the x-intercepts are now situated. So I look, 0 is part of my range. I'm going to have to consider this. But the thing that I know now, it's the maximum value. Okay, it's the high point. So when I think of sine, I have a maximum value that happens once per period, right? Now, typically, my maximum value for sine happens what degrees? Now, I have moved this 60 degrees to the left. So now that's happening at 30 degrees. Does that make sense what I did there? Okay. Now, how many times per period does this happen? How many times does maximum happen? Once. So how often is this going to happen? Perfect. 360 degrees in, NEI. So it's really nice when your 0, your x-intercepts are maximums or minimums. But then do you see how I thought about it a little bit differently? I didn't think about the movement. I'm going back to the shape. Where are my maximums? Where will they be now? Okay, that was a little bit conceptual. How did we do there? Questions on that one? All right. Y-intercept. Well, I'm going to do the same thing. I like going back and just saying, you know what? I'm just going to make my x 0. I'm going to discover the value of the sine of 60 degrees. So I'm just going to say, what is sine 60 degrees minus 1? So I go in my handy dandy funky all-knowing unit circle. The sine of 60 degrees is √3/2. We don't tend to present the answer this way, though. We like it presented as one term. So you'll normally see this as √3 minus 2/2. Now they are the same, but I'm just saying be aware of the different presentations of mathematics. We prefer a single unit if at all possible. It's not always possible, but if it is, that's what we like. All right, do you think you can fly solo and do that last one on your own? I think you can. I believe in you. I worry about x-intercepts? None. 0 is not within my range. My life just got a lot easier. See how you do with the y-intercept. Express it for me as a single term as well. Carl. Good, how are you? No, I'm just in a hard concept. Okay, no problem. Okay, bye. All right. I make x equal to 0. I go for the sine at negative 45 degrees, which is negative root 2 over 2, and I add 45. I don't like that form, so I want to put it all together. So I'm going to have 90 minus root 2 over 2. Most of you probably had negative root 2 plus 90, correct? Now, why is this a preferred way? Generally, if I don't have to start with a negative, I don't. Okay, it's a fewer signs to lose and get mixed up. And when you go into bigger, longer equations, calculus, it's one less thing that you have to make sure made it all the way through. How many of you have already made a mistake to do with positives and negatives? And everybody's hand should be up. Like, you just lose them. So this is just a preferred way because I won't lose that negative sitting at the beginning. Okay, I don't have to tie it into whether it's added or subtracted. So that's the only reason we like it that way. Okay, here we go. Summary of the parameters. Your amplitude is the absolute value of A. Now what you're going to find comes in extremely usefully is you have to realize it's the maximum value minus the minimum value, which is the distance between the highest and the lowest point, and then you divide it by 2. So the subtraction of those 2 points gives you a distance. And then I only want half that distance because the amplitude is center up, center down. Period. One of the things that I don't tend to do, I don't do the absolute value of B, which I really should. I just think you guys kind of know you can't have a negative period. But the period is 360 divided by the absolute value of B, or 2 pi divided by the absolute value of B. Our horizontal phase shift acts just like it did before. It's to the right of C is greater than 0, to the left of C is less than 0, understanding that the negative is part of the equation, so it's just like our transformations. Our vertical displacement is our D value. I like to think of that as the middle, the center, the average, and because it's an average of the maximum and the minimum, I would add my maximum and minimum and divide by 2 to find out where that center is. For example, let's write some equations. Write the equation of a cosine function that has a horizontal phase shift 75 degrees to the right. There is no trick. There is nothing tricky about this at all. It's a cosine function, so make sure you've got cos. If it's 75 degrees to the right, I subtract 75 degrees from the x within the brackets, and if you don't put the degrees sign, you've written it in radians and it's wrong. Okay, I say that almost every class when it comes to trig. If you don't write that degree sign now, I have to assume radians, and it's wrong. Make sure you get that degree symbol. No trick though, it's exactly what it looks like. Just bad habits, guys. We've got to break some bad habits. A sine function having a horizontal phase shift of 3 pi over 5 radians left and a vertical displacement of 4 units up. No trick. I'm sure you guys can do that, yeah?
Should we be using the theta or x?
Doesn't matter. No. So if you wrote theta there, it's fine. If you wrote x there, it's fine. So, sine function. So I make sure I write sine within the brackets. I'll write theta this time because you mentioned it. I'm going to the left, so I'm adding 3 pi over 5. And then I go up 4 units. No trick. There's no trick in these. Identify your A, your B, your C, your D, put them in. So why don't you guys try C? So I said there was no trick, but there was one little extra step you had to do there, wasn't it? I didn't give you the B value. I gave you the period. So you guys think the period is equal to 360 degrees divided by B. So my B value is found by taking 360 degrees and dividing it by the period. So that's the one thing I needed to calculate, but you had the equation for it. So my B value is going to be 360 degrees divided by 120. So my B value is 3. Don't reciprocate it again. We've already taken care of that. That is the B value. So that's the one piece of information that you had to figure out on your own. Okay, now that I've got that, I'm like, okay, is there an A value? I read it through. Amplitude of 1, so I really don't need to say anything. This is a sine function. I have a B value of 3, a horizontal phase shift of 30 degrees to the left, round square, and vertical displacement of 2 units down. So remember, the period is not the B value. The B value is not the period. We've always got to do a little bit of finessing to find that. Does that make sense? So we've got one thing that isn't what it seems. Everything else is really straightforward. The period is not there. We find the period using the B value. Are you okay with that? Okay, try D. If I see that I'm given the period, I know that I'm going to have to use that to find the B value. We're talking in radians, so it'll be 2 pi divided by the period, which is 3, and that's all it is. I have a negative A because it's reflected in the X, and I have an amplitude of 4, so my A is negative 4. It's a cosine function. I found my B value at 2 pi over 3. Pi over 4 radians to the right. And nowhere in there does it say vertical displacement. So watch out for the B value. It is not the period. It is used to find the period. And if you have the period, you do not have the B value. It is used to find the B value. Questions? We're okay with this? Nobody's unclear on anything? Everything's crystal clear? I'm that good today?
Yeah.
Okay. Here we go again. Put it all together. Luckily, we just have to describe the transformation, state the amplitude, state the period, and state the range. So no x-intercepts. Woohoo! All right, so describe the transformations. Let's pare this one down. Let's just say vertical stretch, factor of 2. Horizontal stretch, factor of 4. I'm not going to say phase shift this time because I've discussed that with you guys, right? It should be there. So we're going to say 12, right, 3, up. We're going to pare this one down because I've repeated myself enough there. Amplitude. Just look at the absolute value of A, 2. No trick, it's exactly that. The period. Well, we notice that we're using radians. So my base period is 2 pi. And I divide that by the B value, giving me a period of 8 pi. So the range. So I need to think. I started with a center at 0, and I moved 3 up, and then I had an amplitude of 2 up and 2 down. So I like to think that this is my center, and I went up 2 and down 2 from it. So I just look at that D value for where that center line is. So my range is going to be 3 down 2 to take me to 1, and I'm going to be 3 up my amplitude of 2 to take me to 5. So that D value and that A value are that maximum and minimum. Pretty straightforward. So it's just pulling out that information again. Questions on that? Okay. Work a little ahead of me. I'll be right behind you, but I want you guys to do the thinking now. So reflection over x, horizontal stretch factor 1/3, pi units left, down 4. Amplitude of 1. There'll always be somebody that still gives me -1, so I really, really want to reinforce there. It's a distance, right? It's a measurement of distance, so it's got to be positive. Radians, base of 2 pi, divide by the B value, walk away, it's done. -4, figure out how high and low you're going using the amplitude. So this goes from -5 to -3. Nothing tricky. Nothing tricky at all. Good? All right, guys. 2 more columns. You can do them. Or sorry, 2 more rows.
Can't wait to factor that B value.
Shh. At least I know he's paying attention. Why were you ready? No. Solid. So Nick called it out right away. It's going to be the B value. That's where I'm going to trick you. That's the issue. Did you factor away the B so you could see the proper C? So that's why it's 45 degrees, not 19. So for my range, I think I'm going up and down from that number, the amplitude. So this goes from 1/2 to 3/2. So where am I going to get you every single time in this course? The B value. So if you're always aware of it, good. Got to separate that to see the phase shift. All right, one more. Is there anything on there that I'm doing that you don't understand? Okay. It's all good? Feel happy? Okay, let's start writing some equations based on graphs. We're not only going to write an equation, we're going to write an equation 4 different ways. You heard me, 4 different ways. We're going to do positive sign, positive cosine, negative cosine. Will I ever have you do this on a test? No. But what we are trying to do is get you guys to really understand the phase shift. So this would not be a test style question. We're really diving into C values, okay? So no, I would never ask this on a test. Okay, so I give you the following graph, and we're like, okay, we want to come up with the equation. The best things you can pull out, ladies and gentlemen, where's your maximum and where's your minimum? I've got a maximum of 3, I've got a minimum of -3. So if I want to find the vertical displacement, if these weren't nice numbers, I would say, you know what? I want to add together my maximum and minimum and find the average between them. I want the center, I want the average, I want the middle. Now this one you're like, I can see what it is. I know, but what happens when you can't? What happens when it's not pretty for you? So we really need to keep in mind that for D, we use the idea that it's the average, it's the center. So I add my max and min divided by 2, and of course we can kind of see the middle's at 0. Amplitude, again, this one's pretty and easy, we can see it, but if I didn't know what it was, if I had to dive into it, I would subtract my maximum and my minimum and divide it by 2, giving me 6/2, which is 3. So again, I don't need to do it for this one. I know, I'm trying to teach you something that makes sense. I'm trying to connect the two. Period, okay. When I'm looking for the period of a graph, the easiest thing to use, if you can, is normally minimum to minimum or maximum to maximum. Those are easy points to read. So how far apart are my minimums? Now I used minimum this time because it was on the y-axis, giving me a value of 0, right? Which makes it nice and easy to read. I can see that this has a period of 2 pi. Now, technically, I could have done the same here from pi to 3 pi, but is that just that little bit extra work? You know, take the easy route whenever you can. I like using maximums and mins if it's at all possible. It's not always possible, so when it presents itself, I latch onto it. So I've got a period of 2 pi. We have used this a few times now. I know the b value is the base period divided by the period, making this have a b value of 1. The range, I truly feel this should be the first thing you go get, because that gives you your maximum and minimum. But we can see this goes from -3 to 3. Okay, we are now going to write this 4 different ways. Let's start with the easiest one. Because along my y-axis, I have a minimum. Can you see that that is a cosine that's reflected? Cosine normally starts at the maximum, right? So when I look at this graph, I go, that's a negative cosine graph. So for me, I would jump to my negative cosine and say, I like this to be negative. What was my a value? 3. I'm representing this as cosine because it started at a minimum. I had a b value of 1. And there was no movement, so this was x. And my d value was 0, which I would never, ever write. So for me, the easiest representation is this for that graph. Do we understand why I chose negative cosine? It's that reflection. All right, well, let's write it as positive cosine. Okay, positive cosine starts at the maximum, correct? So let's find our maximum. And I want to see how far it has been displaced from the y-axis. So how far away from the y-axis is the start of the cosine graph, which is the maximum? Well, we can read that that is pi units to the right. That's the displacement of the cosine graph. So when I write this as a positive cosine graph, I just have my amplitude of 3. But now I have to show the shift pi units to the right. This graph and this graph look exactly the same. So, does it make sense? Okay, now let's have some real fun and write these as sine graphs. Okay, let's do sine positive. Sine positive starts at the center and goes up. So there's the start of the sine graph. I want to know how far it has been shifted away from the y-axis. So can you see that this is a shift pi over 2 to the right? Does that make sense to you guys? So this would be y is equal to +3, positive sine, x minus pi over 2. Now somebody's going to say, well, what if I want to use this start? Could I have used that as the start of the sine graph instead it had been shifted 2.5 pi to the right? Sure. So there's many answers it could be for C. I was taught you always use the shortest distance, but truly it doesn't matter which one you use, as long as it does represent a start of the sine graph, which is center up. All right, last one, negative sign. Well, if positive sign starts center up, negative sign will start center down. So when I see center down, I see that. I'm kind of trained to always look as close as I can to the axis. So I see this as a shift pi over 2 to the left. That's the start of the reflected sine graph. So its equation would be negative 3 sine x plus pi over 2. If I decided to use 3 pi over 2, would it be wrong if I used that for my horizontal phase shift? No, I don't care. It makes making up a key really fun for us, by the way. But this equation can be written this graph can be written a multitude of different ways, but they're all the same. Personally, I would just go straight to here, right? If I don't have to write a phase shift, I don't want to write a phase shift. But I can. I just have to understand where the different graphs start. Okay, there's a lot of info there. Does anybody have any questions? Okay, let's do it again. Okay, I want to do my range first because I think those are the most important things to pull out, your maximums and minimums. So I like to say the range goes from -1 to 1. And for me, those are the most important values for finding my A and D. So, because it's between -1 and 1, we know the D value is 0. But if you had to calculate it, it's an average, so you would add your two values together and divide by 2. Looking at that, we can see the amplitude is 1, but if it's not pretty, make sure you think my max minus my minimum over 2. I want the distance, and then I want half of it. And that's why it's a subtraction. What's the period of this graph? Now again, I think this one's nice and easy because I've got a maximum on my y. So I go and I find my next maximum, and I can see a nice easy period of pi. My b value will be the base period divided by the known period. So my b value is 2. All right. Do you see a sine graph or a cosine graph when you look at this? Cosine. Positive or negative? Positive, because then there's no phase shift. So once we determine that, perfect. Let's go write it. Y is equal to positive amplitude of 1 cosine. B value is 2 with no phase shift and no displacement. That's what I think is the most correct answer. That's the easiest one to get to. What do you want to do next? Do you want to just finish up with negative sign? Okay, negative sign doesn't start at the maximum, it starts at the minimum. So here or here. They're actually exactly the same distance, aren't they? So you could have your phase shift as x minus pi over 2 or x plus pi over 2. They're both correct. Okay, they're both the closest. So that's my phase shift. So now I can say this is negative cosine, amplitude of 1, b value of 2, phase shift of positive or negative pi over 2, d value of 0. Does the phase shift how I'm doing it make sense? If there's anything that messes up students, it's the c value. All right. Let's do positive sign. Positive sign starts at the center and goes up. So, starting at the center and going up, I like that. Can we see how that center up started the sine graph? Now that really wouldn't have been my choice, but that's what I'm finding. I've got to be flexible. How many of you went to here instead? That's what I was trained to do, but a lot of students just like to read this way. I don't care. find the start of the sine graph somewhere, and it'll be marked right. Okay, so positive. Amplitude of 1, so I can just go straight to sine. B value is 2. X, I don't know. Let's go plus pi over 4. Because that's truly what I would have done. You could have also had minus 3 pi over 4 if you really wanted to. So you can see my key can get really big. And what I do is I'll have something like this sitting there because that's what I would have done. And if a student comes up with something different, I verify it and then I add it to my key just in case anybody else does it. So my keys get really big here. Are we all okay where those two numbers came from? Okay, try negative sign on your own. Let's see if you get it. I see here, center down. So I would have had y is equal to negative. We're dealing with the sine graph, b value of 2. I would have gone to the right, pi over 4, and vertical displacement of 0. Did anybody have a different c value they want to know if it's right or wrong? Beautiful, you're all doing it my way. Perfect, that's the right way. Okay, you ready to do one all by yourselves? Of course you are. I will recommend for you to start with the range. Find your maxes and mins. That takes you to A and D. How are we doing for the values so far? Max, min, used to find A and D. Is everybody okay with what I've done? Okay, so this one isn't nice to use the maxes and mins for the period, is it? So what are you going to do? I'm probably going to take a nice point that happens to be the center of my graph and say, wow, there's one iteration of my sine curve. So something significant was on the graph. And because the maxes and mins weren't helping me this time, okay, start at the center, which is -2, which will mean it's sine. There's my period. Okay, maxes and mins are really great, but they don't always work. So you have to have other ways. So ABD, those are the easy ones. How are we feeling about the ABD of this graph? Okay, now you've got to go and get all the different C's. Which graph is it if the C value is 0? Is the sine, cosine, positive or negative? Because the center or the D value is at -2, this is the positive sine graph. So it's on the y-axis. That start is on the y-axis. So this would be written as y is equal to +3, the positive sine graph, sine 4x minus 2. Keep on wanting to write +2 today. Can you see how that's the positive sine graph? Okay, so knowing that center line helps. So that's my center line. If I want to do the negative sine graph, where does it hit that center and go down? So the first place I see that it hits the center and goes down would be there. So I like to draw in what I've normally seen as the x-axis, right? Like I see that shift and that's what I'm looking at. So I can see that this is a shift pi/4 to the right. Does that make sense? Okay, so y is equal to -3 sine 4 x minus pi/4 minus 2. Cosine, positive cosine starts at the maximum. There's my maximum. Not pretty, but it's halfway, right? And I've already determined that this is pi/4, So halfway will be pi over 8. So my positive cosine graph will be 3 cos 4x minus pi over 8 minus 2. Negative cosine starts at the minimum. So I see that as my closest minimum. And it's exactly the same halfway between my two ticks. So that's going to be pi over 8 to the right. I find it really useful to draw in that center line when it's not at the axis. It really helps me to see what's going on with sun. Questions on this? How's that feel, okay? I will never ask you to write it 4 different ways. I might give you a graph and say write it as a cosine graph though. I might give you a graph and insist you write it as a sine graph, and that's why you've got to know how to manipulate it. Any further questions on all the different C values? It's C that's going to mess people up. A, B, and D, no problem. C, kids start to really hesitate on. Okay, let's do a practical application. One more, guys. A function whose graph resembles a sine or a cosine graph is called sinusoidal. We don't say cosinusoidal. It's just sinusoidal because it's the same graph. So, the depth d in meters of a water in a harbor can be approximated by the equation blah, where t is the time in hours after the first tide. Graph the function for 2 cycles. All right. Let's figure this out. When I'm graphing, the most important things I need to know to start with is what is the maximum this is going to get to and what is the minimum this is going to get to. And I like to take my d value and add and subtract my a value. So I can see that 12 minus 5 will give me a minimum of 7 meters, and 12 plus 5 will give me a maximum of 17 meters. This is the cosine graph. It has no phase shift, so at the very least, I know I'm starting at 17 meters because it's positive cosine. How has my logic gone for you guys so far? All right, now I need to know if it's 2 cycles. Let's find out how long 1 cycle takes. So let's find out the period. So the period of the graph will be 2 pi over 1/2. The period will be 4 pi. Now, when we deal with real life situations, we default to radians. We use radians for real life situations all the time. That's what we do. Don't change it to degrees. Okay? So, 1 cycle is going to happen at 4 pi, which means 2 cycles are going to happen in 8 pi. Because it's cosine, I know I'm going to hit the maximum at the start, the maximum at the end, and that's going to repeat itself. I also know it's going to hit the minimum halfway in between my maximum, right? So 4 pi halfway will be my 2 pi, and that's when it's going to hit its minimum of 7. Same thing happens here. At 6 pi, it's going to hit its minimum of 7. And to be honest, at this point, that's enough. Please be curved with your lines. They are not straight lines. It's a curved graph. And there are my 2 cycles. We've already answered some of these questions. Maximum and minimum depth. I think, again, that should be the first thing you go get, is your maximum and your minimum. We already figured out what's the period of the tide. And again, watch that note. Real world problems are defaulted to radians. Don't go to degrees. And then we have our practical application. If an ocean liner requires a minimum of 13 meters of water in order to dock safely, graphically determine the number of hours per cycle the ocean liner can safely dock. Now it's a calculator question. We've done everything else without the calculator. Now we need to go and use the calculator. So here we go. We've already got a nice representation, but let's put the information in. 5 cos 1/2 x plus 12. When it's real world situations, I tend to have to go and adjust my window manually. So that's why it's good to do this graphically first, is I have to have an idea. My x min is 0. My x max, I went to 8 pi. So I just want to reproduce my graph. So I've already seen I did 2 cycles. The minimum was 7, but I like to see it properly. So I put my minimum as 0. My maximum was 17, so I'm going to have it go to 20. Now, did we do a pretty good job with our graph? Our manual graphing was pretty good. There's the graphical representation. So now I'm looking at a minimum water depth of 13 meters, right? Is that an X value or is that a Y value? It's a Y value. So I go and I put it in as a Y value. So the ocean liner can dock here, here, and here. Now it wants how many hours per cycle. So if we think of a cycle as this, I would have to add this and this, which is cumbersome, right? That's kind of icky. Is this and this not the same as this? So let's find our 2 intersection points, right? Intersect. So I'll find this intersect, I'll find this intersect, and what do I do to find the distance between them? Subtract them. There you go, nice and easy. Second function, trace. This was not working well for me this morning. I would hold this down and that happens, so I don't know what's going on. So I find my first intersection point, 15.3. That second function, trace 5. Find my other intersection point, 9.8. Subtract 2. 15.3 minus 9.8, because I want to find the distance, about 5.5 hours per day. So our calculator didn't come out till the very end. Okay, most of this we need to be able to do in our heads, know the amplitude, know the maximum, know the minimum, find the period. But for questions like that, where you have to find kind of that intersection, now we're into graphing. Yes?
How exact do you want us to be?
I would have said on a test to the nearest tenth. And so on a test, we're more precise. In our notes, we're more loosey-goosey. Okay, you have a lot of work to do. You have textbook assignment and the assignment on the next page. What I'm here to remind you of is Thursday is a work day. How many of you have already said with yesterday's work, I'll just leave that to Thursday? That's not always a great idea because I'm piling it on. Okay, you can get buried in this quickly if you say, I'm just going to leave it till Thursday. More and more and more is coming. Don't put it down. What the point of that work period is, I want you to work at it, but when your brain feels like it's had enough, take a break. You'll have time, but you can't put it down and completely walk away from it and say Thursday, because this is a lot of work. Trig can bury you quickly and very suddenly. Take it seriously. Okay, so we've got tangent tomorrow, which I can teach in about 10-15 minutes. Then you'll get a little bit of work time to get caught up on top of things. But we're doing application of trig functions tomorrow, which can take, that's a long lesson. So think about the time. And then you have Thursday as a work period, then your test on Friday. Don't leave too much, guys. That's just my warning to you. Trig needs practice. You need to stay on top of trig. Trig needs attention. All right. Best of luck.